Slide 1 title. Hello investors. Today we take an unprecedented deep dive into the evolution of the semiconductor king, TSMC. You often hear terms like process nodes or nanometers, but did you know that TSMC's true strength actually lies in its back-end evolution, its packaging? Info Kowa Soix. And why have they established an R&D center in Tsukuba, Japan, partnering with Japanese material makers? By watching this video, you will see how TSMC is transforming from a mere factory into a system integrator. Slide 2. The front-end journey. Let's turn the clock back 10 years. This is the evolution of the front-end process, drawing circuits on silicon wafers. A decade ago, we shifted from planar transistors to 3D FinFETs, 16 nanometers, 7.5, and now 3. They have advanced miniaturization at breathtaking speeds. Now heading toward the 2 nanometer generation, transistor structures are changing to GAA gate-all-around. But here we hit a physical wall. Shrinking alone no longer provides performance, gains that justify the exploding costs. Slide 3, the paradigm shift. Enter our keyword for today, heterogeneous integration. If you can't make one chip smaller, connect multiple specialized chips as if they were one. This is the strategy TSMC is currently focusing on most heavily. Continuing Moore's law not through shrinking, but through packaging. This is the world of more than more. Slide 4, the mobile revolution, info. The first success story was info for smartphones. In the past, POP package on package. Stacking memory on top of the chip was the standard. But TSMC developed info, which wires directly without a substrate, achieving dramatic thinness and heat dissipation. Its adoption in the iPhone shocked the world with TSMC's packaging prowess. Slide 5. The AI enabler, CoWoS. Now supporting the AI era is the CoWoS series. There are 3 main types. First, CoWoS, using a silicon interposer for maximum performance. This is used in NVIDIA's H100. Next, CoWoS-R, using wiring layers for cost effectiveness. And the one to watch now, CoWoS-L, using local silicon bridges. To connect massive next-gen chips like Blackwell, this L technology is indispensable. Slide 6, the ultimate 3D. The evolution doesn't stop there. SoIC stacks chips vertically, not just side by side. Here, hybrid bonding is used to fuse copper directly to copper without solder. Furthermore, developments like SOW system on wafer, turning an entire wafer into one giant. Computer and future CoWoP for optical integration are underway. At this point, it's less about semiconductor manufacturing and more about precision architecture. Slide 7. Why Japan? Tsukuba. Here is a critical question. Why did TSMC place its R&D hub for these advanced technologies in Tsukuba, Japan, not Taiwan? The answer is, the back end is a battle of chemistry and materials. Miniaturization is a technology of light lithography. But packaging is a technology of materials, adhesion, encapsulation, thermal management. How to keep a warping wafer flat. How to insulate microscopic wires. Japan is the only country in the world with the material technologies to solve these problems. Slide 8, the Japanese partners. Let's look at the specifics. The presence of Ibiden and Shinko Electric Industries, world leaders in packaged substrates, is well known. But that's not all. Advanced encapsulation materials to protect chips, high heat dissipation materials to handle massive thermal loads, and special optical materials for future silicon photonics integration. TSMC cannot mass-produce next-generation packages without joint development with Japanese chemical and material manufacturers who dominate these fields. Tsukuba is the frontline base for this crucial integration. Slide 9. The ecosystem power. TSMC's brilliance lies in turning these into a platform called 3D Fabric. They standardize design rules, allowing anyone to build high-performance chips using this tech. Once inside this ecosystem, customers cannot switch to other foundries. This has become the strongest moat in the foundry business. Slide 10. Conclusion. In conclusion, TSMC's evolution is accelerating on 2 wheels, front end and back end. Investors, look beyond the nanometer race. Focus on who supports this packaging technology. Specifically, Japanese material makers are the unsung heroes of this evolution. In the era of heterogeneous integration, Japan's technical prowess is set to shine globally once again.